matrix and link
All right. Good afternoon. Hopefully, all of you guys are having fun with the Datathon today. Yeah. Was like, how many of you, show of hands, like participate in the Goldman Sachs challenge? Oh, that's good. That's a decent number. You having fun? Yeah. That's great. That's great to hear. Just as an introduction, my name is Suresh Thuma. I am the engineering manager, managing director for public cloud engineering at Goldman Sachs. So one of the exciting things about my job and what me and my team do is we are kind of providing solutions to our fellow engineers. So we have about 12,000 engineers at Goldman Sachs, and our job, our mission is to help our 12,000 engineers to be more productive. Help them to deploy applications, help them write business applications faster, run them securely in public cloud. So it's exciting. I get to talk to a lot of engineering. Not a lot of engineers on a day-to-day basis, and one of the fun things, what I do every day is like, write code as well as like, see the impact of what we do in a real time. And that's the beauty of like, what I do and being an engineer as well. I'm a geek. Spend a lot of writing code, even though I have like 25 years of experience, as a software engineer. So that's a good thing. So let me talk about a little bit about Goldman Sachs and give you a quick overview, and then we'll talk about what we're doing in public cloud and why public cloud is very important at Goldman Sachs, and how it's impacting our business. So, is it moving? So, if you have not checked in, please do check in, so that we have a record of you attending, as well as get updates from Goldman Sachs, from our campus recruiting team. We have our campus recruiting team here as well, and I'll be able to follow up, and again go online and apply for our roles as well. So, what does Goldman Sachs do? So, how many of you have heard Goldman Sachs before this event today? Oh, that's good. Wow, that's awesome. So hopefully all of you have heard Goldman Sachs in the context that we are a tech company on Wall Street. We are like a fintech company, even though we have a 150-year tradition of being investment banking, one of the top investment banking firm on Wall Street. We do a lot of different things. So let me go through like four different things that we do at categorize, right? So what we do first is we help corporations. So I'm sure you probably like use. I mean, most of you use Facebook, Google, like all these tech companies, right? So they all started as a small firm, right? All like started as a startup. All of them are started as a startup. Now, when they want to go public, right? When they want to go when offer like shares to like individuals like us, they need company like Goldman Sachs to help them to take them to market. So what our bankers do is work with these corporations, help them financially plan in terms of how many shares they should be issuing, what is the price of that share, and how do they kind of issue the initial public offering. All that is part of the exciting thing our bankers do. So our bankers are like super smart, like talented, like math, science, all the kind of background. They kind of run all the financial models, into what if scenarios, like in terms of like how should we kind of like for example when Facebook or Google was going public, right? They have all these mathematical models in terms of like, what should be the how should we value a company, right? Because again, when it's not public, you don't know. I mean, it has to start from somewhere. So they have all these like very cool like mathematical models in terms of what the financial model of the company look like based on their revenue, what their future growth is, and they come with this like initial offering, and that's what we do, right? That's what we do with corporations. And when they want like loan to expand, or when they want to acquire another company, like for example, IBM acquired Red Hat. You probably don't know Red Hat, because the Linux company is one of the biggest acquisitions, right? And they need like billions of dollars of loan. Like when you and I want a loan, if we go to a bank, right? And you're gonna want to buy a car or something, you will go to a bank and they lend you money. But when IBM want to acquire Red Hat, it's like billions of dollars of like money they need, right? So they need to go to a company like us, and we help them kind of put structure a debt plan so that we can help them raise that money, and then we go to our investors and sell that debt, right? So, like for example, our investors like invest in that debt so that we give that money to IBM, so they can go and acquire like Red Hat, right? So that's one of the biggest things like we do at Goldman Sachs and help corporations from full service like financial like from like the financial planning to like giving them loans and all that as part of our corporation. That's what our investment banking division does, right? And the second one is financial institutions. Like you would think there's like Fidelity or like Schwab, all these financial institutions are not Fidelity, but a lot of like retirement funds. They are financial institutions, right? They buy and sell stocks as well, like in mutual fund companies. Like I don't know, hopefully all of you heard about a mutual fund, right? So mutual fund is a collection of like stocks. So those companies work with us and we help them go to market. We help them structure and how the portfolio should look like. That's what our traders do as well, right? And when you want to buy like a stock, you go to Robinhood. You buy 10 like units of stock. Like say for example you want Facebook, you go to Robinhood. I'm sure like a lot of you have heard of Robinhood, right? But when mutual funds do, they buy millions of shares of like companies. And when you want a millions of shares of a company you want to buy, you can use Robinhood because, and again, this is like small consumer like companies, right? When they want to kind of trade and buy huge assets of stock, they come to us, right? And that's what do we do with financial companies. We kind of work with them, go to different other brokers as well, and we make markets in the sense like we work and raise that stock or like help them trade on the market. That's one of the things, right? And the third one is the governments, right? You would think like why would government needs money? Government need money, right? So again, government need money like us to kind of fund their growth. Let's say for example College Station or the city of Bryan wants to build a stadium, for example. They don't have money in their bank account to go and like spend billions of dollars to raise something or like build a bridge or like do capital projects like laying out roads or whatever, right? They need money. What they do is they work with our like debt fixed income or like commodity traders or like our company to raise that capital. Like governments are like again, government could be a municipal corporation, it could be a city, it could be a government like we help like government of Singapore, like for example, if they need money like to market, and we kind of sell securities to them and raise money, help them kind of individual projects or capital projects. And that's what we do, right, in terms of like helping governments. And the fourth one, and it's an interesting one, is like individuals. So in our 150 years of Goldman Sachs existence, we're always being doing the first three, the corporations, financial institutions, and governments. We didn't spend much time on individuals because we were not like a bank like Citibank or Bank of America, right? Because we are primarily investment bank. And 5 years ago, we started this whole business, the wealth management business. We call it a Marcus brand. I want to talk about a little bit about that in a bit. But Marcus brand is our wealth management, kind of a brand in terms of providing, banking solutions, bringing credit card. I mean, does anybody have an Apple card? Oh, there you go. Right. The Apple Card, right? So Apple Card is basically behind the scenes. It's Goldman Sachs. Apple Card is just like the brand is Apple, but everything else behind that is Goldman Sachs. In terms of like building, um, the solution front to back. Okay, we partner with Apple, right? So all that is kind of started 5 years ago. We just celebrated 5 year anniversary of starting our Marcus brand. Marcus is our brand for consumers. You will see more and more of this consumer brand out there, which is Marcus. It's more digital bank. That's what we do in terms of like Goldman Sachs. In terms of like day-to-day our businesses. In terms of like our like focus. Now people will ask like, what does an engineer do at Goldman Sachs? I mean, now, what do engineers do at Goldman Sachs, right? So again, the beauty of working as an engineer at Goldman Sachs is that you get to work on a lot of different like engineering problems as well as business, growth opportunities as well. Like for example, like we build massively scalable software and systems. So when I say massively scalable, it's really like massively scalable systems. Like we go from like billions of trades in a year basis, right? We connect with a lot of different exchanges to execute trades. So I tell this, to students when they ask, like, what's the difference between what the engineers do at like technology companies like Facebook, Twitter, and all that, and what we do. Let me tell you. what we do is like, it changes, interacts with money. So like, for example, if you're an engineer at any of the technology companies, you can building cool software, but if you as a user, like at right, being, let's say I'm taking like, for example, Facebook or Twitter, you could lose a tweet, and you're going to make somebody unhappy for a bit, and they're going to recover, like, and say, no, I'm going to retweet or whatever, right? And if you make a mistake at Goldman Sachs, and if you lose a trade, you're losing billions of dollars. And that's how, critical of software that we write. And when you want to write software like that, which is very, very critical, you need, like, really smart engineers. And that's why we go to a lot of universities like you, like TAMU, or like a lot of great universities hire like really smart people, because the software we write is very, very critical in terms, because it deals with money. When it deals with money, when you make a mistake, or like, everything that you do, is it directly impacting the financial products, or the companies, like revenue for, like, companies that we help, right? And then we do that, at scale. And let me tell you, in terms of like the scalability of our software, the performance. We deal with some of the things that we write software. We deal with performance optimization to a nanosecond. The reason we do that, that's very important, is when you write software, when it's trading at exchange, you want to get your trade before anybody else can trade. Because the market changes like every second, like, the prices changes every second. We want to hit the market at the right time. So the software we write, we spend a lot of time optimizing for speed, the execution of a trade. Again, I'm going to take Robinhood example. When you want, trade, like, you might like say, I want to buy, Facebook at like $95, 4 cents. But when we trade at millions of stock of Facebook to our clients, we want to hit the 95.0001, because that 001 makes it adds up huge when you add millions of dollars, right? That's why it's so important for us to write, like, uh, software that is scalable, that performant, and again, reliable. Reliability is a key part of everything that we do in terms of, writing software, right? So in in terms of numbers, we have 30% of our, like, organization, Goldman Sachs, is engineers. Imagine that, right? That even though we are a bank, there's a lot of people like working in the front office, dealing with our, like, clients on a day-to-day basis, selling products that we do. And 30%, like, one third, almost one third of our company is engineers, working with hand to hand with our, like, salespeople, hand to hand with, like, our wealth advisors, developing solutions so that to help our business, our client, our salespeople, or whether it is our, like, HCM, or whether it is like, our wealth advisors, so they could offer better products to our clients, right? And then, we have like 1.5 billion lines of code. This is like, years of engineering. We have like thousands and thousands of applications that deals with every aspects of a financial, like, business, from, front office, like, you writing a UI to for that, so that the clients can interact, or writing a mobile app for our Marcus app, or writing an app, backend app for, so that Apple can, have APIs, so that they can, like, call our APIs to open our websites, if it's going through our APIs. I mean, imagine when you swipe a card, or when you use Apple Card at some business, you have like seconds to, kind of process the transaction, right? So that, and again, that's all part of our, like, scalability and performance, app code that we write. And then we have like, 16 million, applications, right? So that's the agility of what we do, right? Because again, we have like so much in terms of, like, on a weekly basis, we have like so many releases that we do across all our portfolio. The portfolio is huge in terms of, like, you talked about, like, all those four businesses, the impact is huge, right? And then, we have like 2 billion trades executed per year, in terms of, like, the software we write, like, it's huge. I mean, in terms of, again, those 2 billion trades, like, deals with trillions of, like, revenue for the firm, for our clients. So that's the scale that we deal with, and that's why, we have, kind of look for really, really smart people, really talented people to kind of come, join our organization, so that, so you can help us, like, be like provide better service to our clients. And then from an engineering perspective, we have about like 18 different divisions in Goldman Sachs. And the cool thing about being engineering is you get to work across all these different divisions, from, our consumer wealth management division, which is basically our Marcus brand. This is where, we kind of offer solutions, whether it's Apple Card, whether it's Marcus, like, loans and savings, all this like Marcus Invest, which is basically our like, consumer investment platform, automated investment platform. All of this is part of our consumer investment management. Global investment research, I mean, this is where our investment research analysts are researching about the firms and offering advice to our clients, right? And then we have like global markets. I mean, global markets is the division that deals with trading across the globe. Not only in the U.S. stock market, but across the globe in terms of trading stocks. Like offering like fixed income, which is like debt solutions. All that is part of our global markets. We have like a huge risk division. One of the secret sauce, if I could use that word, is with Goldman Sachs is our risk division. Our risk division like has like amazing product called SecDB. This is like a custom developed solution, and that's something that unique to Goldman Sachs. And this is like, again, just to give you a scale, SecDB is our risk platform. The foundation of a risk platform runs like millions of like billions of like what if scenarios every night. We have like millions of like computing power on a nightly basis at Amazon and Google and then on-prem, doing all these Monte Carlo simulations in terms of what happens something happens to the firm. Like for example, like if the weather is bad, like I'm just taking an example, simple example, in one part of the country, how does it affect our balance sheet? How does it affect our consumer, our like client balance sheet? All those things are done by our risk division. So on a daily basis, they are the ones that kind of looking at the risk, because again, probably but Goldman Sachs can survive and kind of still like one of the only firms, I would say, kind of it being intact, and that because of our risk division, because we saw the risk a lot ahead than a lot of other companies did, and that's because of our systems, our technology that we have, and that part of the risk division, and they do a lot of really cool stuff. Again, the good thing about being in engineering is that you get to work across all these different divisions, and then we have a great internal mobility program in terms of going from one division to other division, and kind of explore across all the different divisions. So now let me talk about our Marcus, which is our consumer wealth management. As I mentioned, for many years we were just primarily focusing on corporations, financial institutions, and government, right? But again, 5 years ago, we saw an opportunity as the digital, revolution, kind of picking up. We kind of thought about like, again, how do we kind of serve our consumers? We didn't want to be just like Bank of America. We didn't want to be just like Chase or like any other bank. And when we kind of go into a market, we want to be a change agent. We want to be an innovator, and that's where we started. Like 5 years ago, started digital bank. So when you see Marcus, you will not see a bank like named Marcus, or like a store or like a branch, name it Marcus, right? Because you go to like you see a lot of branches, Wells Fargo and all, Bank of America. You will never see a Marcus branch, because we are all digital bank. And the power of digital bank is we get to innovate faster. We get to provide solutions to our consumers, digitally, and they can, so that they can make financial decisions faster. They can manage money better in terms of everything that we do. And then that's where we kind of introduced the Marcus brand, and we started off with like a savings account. Now next year we're going to have a whole suite of financial products, everything digitally. And that's the cool thing we do, and a lot of other companies are kind of following us. And again, that's the beauty of being at Goldman Sachs, is like we get to innovate much faster than any other company, and all because of the thing that we did foundationally for years, right? And then we'll talk about like how Marcus brand kind of evolved, right? Again, 5 years ago when we started this, we did everything on cloud. And the reason cloud is very important to us is it is basically empowering us to be more agile, to be like to introduce more product, introduce new businesses, quickly into the market. And that's the power of cloud, and that's why cloud is very important in terms of everything that we do here. So let me kind of quickly, before I go into technical details, let me play you a quick video in terms of our CEO talking at reInvent in 2019, and I was there in person to watch it. of we had opportunity to work on like really cool stuff. Transaction banking is one of our like latest innovative product, again all digitally, like providing kind of consumer like solutions to invest in like big corporations. And that's what transaction banking does in terms of like everything built from ground up on cloud, so that we can innovate faster. Now let me talk about a little bit about the nuts and bolts of like how we're doing it. Again, I'm sure a lot of you have heard different cloud providers. We have like Amazon, Microsoft Azure, and Google Cloud. We are primarily like again, as probably heard or learned about this. Amazon is the leading cloud provider. Google and Azure are catching up. But again, Amazon is still the leading provider because they are the first to market. They are they have like about 200 different or more than 200 like every day innovating, and more than like coming up on a every year, and like kind of really changing how compute is used for like business applications. And this is the kind of web services is basically the biggest, like it has a huge market share. In the next like few years, other companies are going to catch up. But again, I see Amazon like still leading the way. Now let's talk about like different types of cloud computing. So before cloud, right now as David Solomon mentioned, like the typical like legacy is like we have football fields, like multiple football fields of length of like data centers, in the sense like floor space, huge computers, like sets of computers like that we buy and rack and stack. In a typical like pre cloud world, it used to take us 6 months to get a server like getting ready to getting ready for developers to kind of build applications or like deploy applications, right? So you kind of basically go to like a company called Dell, go to their use their like ordering process to order like computers, and it takes months for them to ship it to us to our data center. Now from there it takes weeks for our engineers to kind of get that computer, find a place to rack and stack. We call rack and stack. Basically put that computer, power it up, build network for it, and then getting ready. And then from there, our engineers to put operating system, which is basically operating system that are customized for Goldman Sachs, right? And then from there, checkout process took us like months. Now imagine you didn't have to do that. Like the analogy that I always give people is like for cloud computing is, think about owning a car. If you own a car, like you got to make sure you are responsible for like going to dealer, buying it, and servicing it, like having a place to park it, kind of the whole 9 yards. You own it. You buy it with your capital. But imagine you have a way to kind of not buy it and just rent it when you need it, and it's much more economical just to rent it rather than buying it. And imagine like you just have to let's say you go from place A to B, and you just need that car just to go from A to B, every like every day or whatever, right? You don't need to buy that car and have to own and maintain it, right? And imagine that you get a car within seconds of you need it, like hopefully Uber will get there one day, and stuff like request Uber like to wait 10 minutes instead of waiting for 10 minutes. If you imagine if it's there like the moment, like a few seconds later you get it, and you would use that service, right? Because it's like very economical, and you don't own anything in terms of like managing that the life cycle of it, right? The same way compute is kind of the same way. Traditionally we bought that like that compute power, used our data center to park it in our data center, had power, electricity, all those things are managed by us. Now with cloud computing, we don't have to worry about any of that stuff, right? In terms of like we just rent computers when we need it, and that's why we have like three different types of services. Cloud is just not one big humongous thing, right? There are different types of services. IaaS is like basically still like think about a car analogy is like you still rent a car, you're still responsible for it while you have it. Like you go to a rental car and buy it, and you still drive it, you're responsible for it. The same thing, IaaS is basically you're going to a cloud provider and getting a computer and then renting it for a time. And while you're renting it, you're still responsible for like making sure you have the right operating system, making sure the security is managed by you, and all that is part of that, right? So that's part of IaaS, and we use IaaS service for a lot of our risk compute. because again, this is the software we write. It runs, on our operating system. So we just go to Google and Amazon. That's where our risk compute runs. We just rent the computer, put our operating system, put our software, and run it as many. Again, imagine this: for risk calculation only to run during night. During the rest of the day, we don't pay anybody. We just because we rent it when we need it and we give it back. And that's the huge power of cloud computing is pay as you go, right? Or pay when you use it. And we save millions of dollars on a yearly basis because now typically we used to own the computer, run it, and then during the day there's nothing happening on it, right? Now with cloud, with IaaS service, we just pay when we use it, and after that, we run it, right? That's IaaS. And the platform as a service is like a unique another concept. Kind of analogy is like getting Uber, right? You don't drive it. The owner of that car is responsible for maintaining it. Maintaining the clarity of it, making sure he's the one who's driving it. You just ride that. And platform as a service is kind of a similar concept where you don't own the computer. You just write code, give it to the cloud provider, and then they'll run it on their platform. The beauty of this is, again, you still pay for what you use when your program is running, but you don't own any of the compute power. You don't get to decide what computer it runs on. For example, AWS Lambda is a serverless solution. If you're writing code, you just write code and then deploy it on AWS, using the AWS Lambda, and then they deploy it on their fleet of computers, right? And then you don't manage the operating system. You don't need to worry about the security of it, in the sense making sure that the service secure. AWS does that. So this takes away a huge burden of our day in day out in work that we do, right? We just focus on writing applications, and more, we are my team primarily focus on platform as a service. All our engineers in my team is basically helping our engineers to use platform as a service securely, and that's what we do day in day out, right? In terms of building this cool solution so that our engineers can write securely this application that can run on a serverless platform. And the software as a service is basically, this is your Office or Google Apps. You're not writing software. You're just using that software as a service, right? You don't own the code. You don't own the server. You just use it as a service. Typically, before for example, Microsoft Office, and we all use Microsoft Office, right? Now with our email. Typically, before that, we used to run that software in our data center. We used to have engineers managing it, right? We just pay Microsoft. When we hire a new, for example, when some of you join as college hires, we just go to Microsoft and create an account for you and done, right? We don't do any life cycle aspects of how your account is managed or whatever. Microsoft or Google, software service provider runs that. And more, again, all these software service providers, we use more of SaaS services, because traditionally, ServiceNow, for example, is our ticketing platform. We are just migrating to ServiceNow. Again, the good thing is that's not our bread and butter. We just use it as a software service. We're the vendor when we use it, and when we don't use it, we don't pay for it, right? That's the beauty of all these different services. And this is how companies are innovating. Every company has a flavor of any of these different things, right? We have, some of them have IaaS, we have PaaS and then SaaS. And that's what cloud computing is more effective, because every company can decide what type of service they need, how they can efficiently manage their compute power. Now, public cloud, why is it important for us? Why is it public cloud is more appealing to us, right? The availability and resiliency aspect of it. Think about this, right? We have applications running, for example, on Amazon in different regions because of the availability. Laws of physics, things can go wrong. Amazon, Amazon things in Amazon can go wrong as well. Sometimes we have a problem in a whole data center or a region, right? And that's why we deployed in multiple regions for availability and resiliency, because we have that flexibility. Now, think about this, right? So if you want to run an application before cloud, in London, we have to build a data center there. Now with cloud, we don't have to worry about it, right? We can deploy it across multiple regions and run it in multiple like availability zone. We call it availability zone because there's like fault tolerance built into all those things, right? That's one of them. And then scalability, elasticity, and scalability. Again, this is a huge part of why cloud is so important for us. As we scale. Like for example, when we launch markets, right? Initially, we probably need like capacity to have like 1,000 or even millions of users. We just the power of API. We just scale it automatically, and that's a huge benefit of using cloud. That's how we kind of scale our businesses or build our businesses as we grow. Scalability is a big part of it. Hey, this is like in traditional world, like we have like petabytes of data. We buy storage from EMC, which is like a vendor, like like Dell and big storage units, right? Now you can just scale petabytes, put petabytes of data on cloud. Like so, some of you were participating in our datathon today. You know, think about it, right? So Snowflake is a cloud database. Think about like with no boundaries. Like if you have a computer, you have a limit of how much storage you have, and after that, you got to buy a physical device. And the beauty of cloud is there is no physical device to buy when you run out of cloud. It's automatically scales, right? The volume of data is like limitless. The amount of data you can put in, and that's why companies like Snowflake and other like cloud data providers are becoming more and more popular because there's no limit of data that you can put in there, right? And then in the infrastructure service, in the sense like everything is like scalable, and that's how kind of cloud is important to us. And then what are some of the challenges? Again, I'm sure like like anything else, there's a good part of it and there's a bad part of it. Not bad part of it, there's like challenging part of it. And that's why we have like really smart engineers at Goldman Sachs. Like security is a huge aspects of everything that we do. And my team on a day-to-day basis, the biggest like thing that I worry about everything that we do is security. The reason like security is a huge aspect is like again in a traditional data center, you have a physical boundary or virtual boundary around your assets, right? That is like a wall, security wall that you need to cross that wall to get into your data, your security, your like your servers. In cloud, everything is public, right? And now only software through configuration we can make it secure. The reason we worry about security is it just makes like make one mistake by engineer to flip a flag to go from private to public, right? Then people might ask like, why can't everything to be private? Because there's parts of our business we want it to be public. Like there's parts of business we want it to be private, in the sense like part of our servers. Like if you look at our Marcus brand, a lot of our services that we write are public facing, and some of our servers are internal facing, that are like like back end, for example, right? The front end is public facing and the back end is all private, right? We don't want anybody try to connect to our back end services. And now the difference between the public and a private server is just like one configuration item. And imagine, one of our engineers made a mistake of like, flipping that one flag, or like when you're writing code, like if you say, dot private is equal to false or true, whatever, right? That could expose us in our data, right? That would expose us to kind of serious challenges in security. And that's what, public cloud, again, it's good in terms of it's scalable and all that, but at the same time, security is a huge challenge for us. And, there are moments that, that I wake up in the middle of the night and say like, man, imagine that our engineers made one mistake that would expose all of our like client information on public cloud, because there's all sensitive data, and that's what we do, right? That's what we focus on. Part of like my team does is like we kind of manage security posture of our application in public cloud, right? And that's what we do. And some of the things that we do, like for example, authentication authorization model, our identity, all that is kind of managed in terms of like how we do on day-to-day basis in terms of like our engineers. That's why our engineers are kind of very important in how they do their work in terms of how they kind of design their applications. And my team also acts as advisors to our fellow engineers how they should be writing their software, how they should be doing their configurations. And that's what we do all those systematically. There's no way for us, we have 80 engineers in my team. There is no way all 80 engineers can like service like 12,000 engineers. All that's programmatically enforced. For example, one of our system, we call it Skywatch. That kind of manage my team. The job of that Skywatch team, that platform, is to detect misconfigurations, and then detect misconfigurations, and then automatically change that configuration, right? So think about like doing the classification. If suppose something has to be private, and somebody made a mistake, and again, we have a gap of like maybe like few minutes when somebody deploys something and then the detection catches it, and we don't want to kind of even take the chance of like having a second of like delay in terms of catching that. That's what our engineers do in terms of like day-to-day basis. Again, we have a huge cybersecurity team, and their job is to kind of detect problems, cybersecurity threats before even they become a problem for us. We have a huge cybersecurity kind of presence in Dallas, and if you go to their like floor or their work area, they have huge monitors like look like a space center, right? In terms of looking at all the things that's happening around the world. Again, their job is to be proactive. They are kind of the first line of defense. Seeing problems before it becomes problem for us, right? Kind of using mitigation factors to kind of deflect off of hackers. I mean, there's like crazy people out there, really smart people, smart engineers. They're hackers. Their job is like trying to find vulnerabilities and kind of steal data from us, right? And that's what our cybersecurity team does, is like detecting problems before it happens. And then again to make sure that we kind of design secure software, is like we have principles in terms of like everything that we do here. Like when we do go to cloud, we have to be design cloud first, in terms of like we need our engineers to be trained so that they know consciously that they're writing software for cloud. There's a difference between writing software for like running in a secure, like in an on-prem, where you have a virtual boundary that you can assume. You can write, you don't have to worry about, like, because there's a security perimeter around you. But when you go to cloud, we want our engineers to think that they're out in public, that everything that they write, their configurations, their security model should be part of everything that we do. That's part of our like security first architecture. In a sense, like we want our engineers to think about security before they even write line of code. How do we make sure that when there's a problem, how do we kind of remediate, or how do we detect those problems, and all that is part of our security first architecture. And then then infrastructure, again, when you request a software, I mean, a server from cloud provider, we don't want our engineers to go to a UI and click through. Like you probably, for example, today when you participated in a hackathon, you went to a Snowflake website and click through buttons. Our engineers don't do that. They don't have the luxury to kind of scale and go to clicking buttons and requesting infrastructure. We do through infrastructure as code. We use a framework called Terraform. Terraform is an infrastructure as code like framework where you write your needs infrastructure in code. Like just you write code to run like data processing. You write code to model your infrastructure, so that we can recover from that infrastructure, from recreate that infrastructure through code. And that's the beauty of like using infrastructure as code. If you had to do everything manually, and if you have to recreate it, you got to find the guy who did it before, like, and have him click through. With infrastructure as a code, it's an artifact, it's code. Anybody can run that code and recreate that infrastructure at any point of time. And that's the great thing about like having some of these principles, is basically helps us to be disciplined about how we write applications, help us to be disciplined about like being cloud first, and help us discipline in having security in cloud. And that's what makes us successful in terms of adopting public cloud at scale. And that's how we are successful so far, in terms of like going to public cloud, because of all these principles that we kind of enforce, or like have our engineers to kind of think through this. And that's why we kind of look for talented engineers to kind of make sure that they have followed the principles of writing code. So this is again, kind of at a high level, or shared responsibility model, in terms of like, again, there is a responsible model in terms of your vendors, because again, the vendor provides us, the cloud provider provides us the infrastructure, and we kind of make sure that the responsibility kind of where the responsibility ends and where our responsibility starts, right? I mean, that's a very very thin line in terms of like where we write our where we kind of own our software, where we kind of rely on our AWS, like on the cloud providers to kind of responsible, because again, there needs to be a very clear delineation of who's responsible when a problem, when something goes wrong. The share responsibility model is where we kind of rely on, like, who needs to kind of, work on to mitigate a problem. When there's a security threat, right, in terms of, like, a problem arises when the data is leaked, there's a there's a shared responsibility model between our cloud provider and us. And our engineers are the first ones to hop on a problem, right, when solving a problem, and we got our vendors on board. And we use this shared responsibility model to kind of make sure we are working very hand in hand to kind of mitigate risk and solve problems. And that's very important in terms of, like, in everything that we do at Goldman. So that's kind of, at a high level in terms of, how we're using cloud, leveraging cloud to kind of, be drive agility and drive innovation and growing our business at Goldman Sachs. Our goal in the next 5 years is to kind of move from our, like, legacy infrastructure running in a data center to move everything to public cloud. The benefit of everything running in public cloud is now we can innovate faster. We can grow new business, introduce new businesses, and we can be the game changer. We are, again, one of the things that David Solomon talked about, having a financial cloud. One of the things that we are working on is building a financial cloud so that other financial companies can leverage in our services. Like, for example, what Snowflake is doing in data. They're providing you a data set, right, so that you can leverage. The same thing we're doing in cloud, so that other financial companies can leverage us as a service, right? So, for example, like a trading model, risk as a service. Think about risk as a service. They can run our risk model without having them own anything in public cloud. And then we have, like, huge roadmap and huge, like, plans to kind of leverage public cloud to kind of change how finance is kind of viewed, and how kind of financial, like, world is going to be evolved in the next few years. And we have 150 years of tradition of, like, doing things, and now next, like, 150 years, hopefully it's going to be, like, we're laying the foundation now using public cloud, right? And just to quickly, again, if you're interested in pursuing a career, we have, like, 4 different, different, like, lines, different roles. Most of the roles are kind of software engineering role. If you are really, like, love coding, you even love data, software engineering role is for you, and you can explore any of these roles. This is a kind of recruiting process. And our recruiting process, you go apply online, and once you apply online, the first thing is, like, we give you a coding assessment, which is HackerRank. Once you do HackerRank, some of you have probably did HackerRank, and then we do a higher review, which is basically a systematic, like, way to kind of interview you, and then the next step is, like, super day. So we're really excited to be here today, and hopefully, all of you, good luck with your Datathon. Hopefully, you'll win our data challenge, and make sure you apply. I mean, this is, again, Goldman Sachs. Again, the great thing about Goldman Sachs is we are, like, an innovative firm. We are a tech company on Wall Street, and that's what differentiates us versus any other investment bank. We are a technology-first company. We kind of have, like, really smart engineers. You'll get a chance to work with, like, really smart engineers on Wall Street. Again, they're developing very critical systems. So with that, I will, like, leave you. If you have any questions, we have Steve, from our HCM team, stop by our booth, stop by our table, I should say, and come and ask us questions. More than happy to kind of help you understand, some of the roles that we have, and the process as well. Great, thank you.
All right, guys. So that was the last workshop of the day. If you guys want to know more about, like, what we have planned after this, obviously we have our event schedule online. But other than that, just keep hacking, and good luck, guys. Thank you.
Thank you, sir. Thank you.